So, hi everyone. So we can start our first session. Actually, this is not a demo session. This is class 1. Class 1 will be starting with HVAC only. Before that, see, when you people were inquiring me regarding the course, I have sent three videos with you. The first one, the things you should know before selecting MEP BIM as your career. Whether you are an experienced professional or you are planning to enhance your career in MEP or you are starting your career in MEP, that video you should watch. I have explained there. And also in message number 1, I have attached 2 videos, class number 1 and class number 2. That video I have shared with you to get a clear understanding regarding the activity that we are going to perform in the MEP industry. Correct. For example, like every projects we are having 3 party. The first one is called the client. The next one is called the consultant. The third one is called the contractor. For example, if I need to construct a hospital, I am the client. I will be approaching a company called the consultancy. What the consultancy will do? Within the consultancy, there is architect, MEP engineers, structural team, soil, QA/QC, QS and estimation, planning department, modeling department. So all the technical documentation, including the design, drafting, QS, Revit estimation, all the necessary initial things, the consultant only will be doing. Okay. And the third party is called a contractor or contracting company. The contractor company will be constructing the project under the guidance of the consultant for Mr. Client. So it is not mandatory to become all the 3 parties like individuals. There might be organizations as well. Okay. So that's why you have to watch the 2 videos. That's why I have shared with you. When you're watching that 2 video, what all services, because from the feasibility study of a project to the facility management in the last, the clear path you should have an understanding, no? Then only the services that you are going to give in a company, you'll be getting a clear understanding. So if you have missed that video, please watch it. I'm not wasting that time again because it is not necessary. Those things are not necessary to study our design part or drafting part. Okay. So that's why, but if you have missed it, please watch it. Then only from the starting of a project to the testing and commissioning or facility management, you will be getting a clear understanding. Because as you know, MEP is not only design. Normally people might be thinking that MEP is the activity that we are going only at the execution sites. No, MEP is design, MEP is drafting, MEP is quantity surveying, MEP is estimation, MEP is building information modeling, and it is execution or construction. Then testing and commissioning, maintenance, procurement, contracts. So nearly 10, 11 activities will come in between. You're not going to work everywhere. You might be going to work in 2, 3 departments. That everything I have explained in that class 1 and class 2 that I have already shared with you. And I have sent a special voice note to everyone. To get a clear understanding regarding our course, please watch the 2 videos. If you have missed that video, please watch that. Okay, no problem. Still, now also you're having time. See, in this course, nearly like 8, 9 courses are combined. We are going to study the full course only. Building services engineering. You don't want to study the courses separately. Whether you are from electrical background or you are from mechanical background, we will be studying the same topic only. Why? What is very simple. Whether you are from 0 year of experience or you are having 35 years of experience, we'll be studying the same content. See, why the electrical engineers are studying the mechanical concept or the mechanical engineers are studying the electrical concept? Because, okay, if you are going to work in a big company, big companies, they will be handling the like very huge project, or the volume of work they will be handling will be very high. So like 1 or 2 engineers, it is not possible to handle the entire activities like. So that's why in that company, we might be having separate department for HVAC, separate department for firefighting, separate department for electrical. That also LV side separate, HV side separate. But if you are going to work in a medium scale company or in a fit out company, those companies will not be having that much money to accommodate separate engineers for electrical and mechanical. Not only that, if you are going to work in a quantity surveying section or in a building information modeling, sometimes you have to handle all the services. That's why experienced professional, that is mandatory, because once you became the team leader or once you became the assistant manager, you have to handle everything, right? You have to handle the entire team. So that's why we have to study everything. Preference will be for those guys who knows everything at the time of interview. Correct. That's why you'll be studying the same concept. Fine. So in this course, we'll be studying design. Initially, each and every topic, whether it is a theoretical subject or if it is a design or if it is a software, each and every topic we'll be starting from the basics, then we will be moving to the advanced level. For in case of AutoCAD or Revit, Revit and all, you can study from any software institutions as well. But the software institutions will teach you only the softwares. But when we are studying in a skill development program, we will teach you the basics of the software at the same time. Using that software, how we can implement a project in it, that only we will be studying. How you can use that software in an office environment, that only we are going to study. Okay. For example, initially we will be studying. Once that has completed all the design, we will study the design. Each and every design will be starting from the basics. Then we will study drafting. Then we will be implementing designing and drafting in AutoCAD. We will do the project. Once it has done, we will study how to do the quantity surveying and how to prepare the quantity takeoff sheet and BOQ. Once the BOQ has prepared, we will be studying how to do the cost estimation. Once all the conventional design methodologies has completed, we will be moving to Revit. And within Revit, we will be doing our building information modeling. Building information modeling, not only because of Revit we are doing, by the help of Navisworks also. Means this model we will be incorporating with the Navisworks. Then the 4D simulation, quantification, clash detection, animation. All those things we will be dealing there. But you guys are not in a position to discuss everything. Just for your knowledge, I told. Okay. I'll be directly starting HVAC. Okay. See, in MEP, we are having mechanical.
May I ask?
Yeah, please.
So today's one, you said is demo, or not, you are starting the HVAC properly?
I'll be starting. Actually, this is, you can consider this as a demo or a free session. Actually, I'm not conducting this only as demo because this is our first class only.
Okay.
This is our first class only. So, but first class anyone can attend for free. Understood? Yeah. Okay, everyone. Then see, under MEP, mechanical, electrical, plumbing. Below mechanical, we are having two services: heating, ventilation, and air conditioning, plus fire fighting. Below electrical, we are having lighting circuit, power, data, PA system, fire alarm, CCTV, solar, UPS. All those things will come under electrical. Below plumbing, we are having water supply, drainage, yes, like irrigation as well. We will be starting with the HVAC only. And initially, we will be going to discuss standards. Okay, what is HVAC? As you know, MEP is related to the construction industry. As long as there is human life in the world, there should be buildings, there should be infrastructure development. So we have to give services. Okay. And under HVAC, we are dealing with heating, ventilation, and air conditioning. Okay. What is heating? Heating, as you know, everyone is familiar with the heating. For example, if you're having a space, okay, and within atmospheric temperature is like, let's say like 14 degrees Celsius. Inside your room, you need 22 degrees Celsius. So with respect to the atmosphere, the space temperature has to be increased. That is called heating. You have to heat your space. But whatever the heating medium that you are using, whether that is electrical heating coil, or if it is hot water with boiler system, or it's a radiant cooling, whatever it may, we have to heat the spaces. So what all equipments that we can use to heat the spaces and how we can do the heating and the cooling load calculation, everything related to the H heating, we'll be discussing with the H part. Okay, heating system. Now we have to deal with the V part. V means ventilation. Ventilation, okay, in residential kitchen, we will be having a small window. People used to say that is ventilator. Okay, that is an accessory. Fine. We are dealing with a process. Ventilation is a process. Why? As you know, all the air-conditioned spaces are 100% sealed only. It is tightly covered. Because it is not practically possible to provide air conditioning system in a closed open space, because since it is having atmospheric exposure, always whether there is a cold air or if it is a hot air, the atmospheric air will be entering into the space that will affect the comfort. So your air conditioning system is not in a position to withstand that. So that's why air conditioned spaces should be tightly sealed. For residential point of view, within a bedroom, we are having just 1 or 2 number of people. Let's say maximum 4 number of people. So we are having sufficient volume of oxygen within the spaces, so the people can inhale it and they can exhale it. For 1 or 2 days, if it is tightly sealed, that is sufficient. But for industrial spaces like offices or classrooms and all, number of people, or especially in a meeting room and all, number of people we are having within that spaces will be high. So since that space is tightly sealed, it is 100% vacuum, it is not possible to achieve. But even though that is tightly sealed only, no atmospheric air is entering inside. It is very less only. So people will be continuously inhaling the oxygen or inhaling the air, and they will be exhaling the carbon dioxide. Eventually, the carbon dioxide percentage concentration within the space will increase. The oxygen concentration will decrease. So what we have to do? We have to dilute the carbon dioxide percentage, and we have to increase the oxygen concentration. But more precisely, we have to maintain the IAQ. IAQ is called indoor air quality. So indoor air quality has to be improved. How? We have to introduce atmospheric air to the space. Oxygen rich air has to be introduced within the spaces. We can't simply introduce it. We have to cool it. Or if it is in a winter condition, we have to heat that air. Then only we can introduce that, right? At the same time, from toilet area, kitchen area, from all those spaces, the air should not be circulated to the surrounded regions. So from kitchen areas, toilet areas, we have to take that air and we have to expel to the atmosphere. That is called exhaust system or extract system. Simply, to maintain indoor air quality within the spaces, what all scenarios we can do, what all process that we can do. For example, if you are designing a gymnasium, each person, how much liter per second of air has to be introduced to maintain the indoor air quality. Each meter square of floor area, how much liter per second of air has to be introduced. All those things we are dealing with the V part, ventilation. Clear? Correct. So that is HV. The third one, AC. AC, we are having air cooling and air conditioning. Air cooling, just the temperature within the space is decreasing. That is called air cooling. We are having a lot of air cooling equipments in the market. What else? So you might be having a ceiling fan or a table fan in your space, right? Table fan or a ceiling fan? Yes, table fan or a ceiling fan. These are cooling equipment only. But it is not an effective cooling technology. A ceiling fan is utilizing the air expansion process. What exactly it is doing? The ceiling fan will be taking air from the top side, and after that it will be expanding the air through the leaf. Air expansion means the pressure is decreasing. If the pressure is decreasing means the temperature will also decrease. Correct. So this less temperature air is directly hitting on our body surface. We will be feeling some cooling effect, right? But the disadvantage is you can apply law of conservation of energy. Okay, anyhow, we are not going to study all those theoretical subjects in detail because we don't want that. We are not going to write any exam. Rather, we are going to work in companies only. But simply apply. What is law of conservation of energy? Energy can neither be created nor be destroyed. Rather, you can convert the energy from one form to another. Okay, so normally you can apply that one. Initially, you will be providing electricity, electrical energy. Okay, so the electrical energy will be converted into mechanical energy. How? The mechanical rotation. Now the mechanical energy will be converted into kinetic energy of air molecules. That's why the air molecules velocity will increase. Then this high velocity air molecules will collide together. It will be colliding together. Then the kinetic energy will be converted into heat energy. So finally, the last product is the electrical energy will be converted into heat energy only. Actually, if you are having a 60-watt fan inside your bedroom, this fan is watt is joules per second only, correct? So the fan is adding nearly 60 joules of heat in your space in each second. 1 second it is ejecting nearly 60 joules of heat in your space. So fan is not an effective cooling method. Fan is a sensation. It may create a sensation since it is a direct cooling technology, but effectively the fan will increase the room load. Okay. Any other cooling method you are familiar? Any other cooling method? Yes.
Air conditioning.
Air conditioning. I will come to air conditioning. Now I am discussing with the air cooling only. Air cooling technology. We are having a lot of air cooling technology. The one is which one? Ceiling fan. Yes, we are having desert cooler or evaporative cooler. Correct. Evaporative cooler. What is evaporation? See, whenever the water is evaporating, it will produce a cooling effect. For example, if you are having a bottle of water. Correct. Let's say the water temperature is 20 degrees Celsius. You are trying to add some heat in it. When you are adding the heat, the liquid water will be absorbing the heat. And once at 1 bar atmospheric pressure, once the water temperature has reached 100 degrees Celsius, you are still adding the heat, you are not removing the heat. At that point, the excess heat, the water molecules will be absorbing. Then from the liquid phase, the water will be changing into vapor. Correct. That's why if the water needs to be evaporated, evaporation of water means from the liquid, the water will be changing the phase into vapor. Correct. We will be discussing detail this thing in the upcoming classes, psychrometry especially. Correct. But one thing, if the water needs to be evaporated, it needs latent heat. Latent heat is the hidden heat the substance is using for phase difference. Don't worry, in the upcoming classes, we can study latent heat of evaporation, latent heat of fusion, everything in detail in the upcoming classes. But just for your knowledge, if the water needs to be evaporated, it needs heat. So all kind of evaporation, in background, it will produce a cooling effect. For example, when you are washing your face, with the water, you will get a cooling sensation in your body, face especially. Why? Because when you are washing your face, the water molecules within your face has to evaporate. So if the water needs to be evaporated, then it needs heat. That heat is called latent heat of evaporation. So the latent heat of evaporation, the water molecules will be absorbing from your body only. So your body will be losing the heat, your body cools. That's why all kind of evaporation in background, it will produce a cooling effect. That's why this evaporative cooling technology we are using in a lot of, for example, chilled water system, we are having a cooling tower. It's an evaporative cooling technology only. You might have seen this equipment before, desert cooler. Okay, in Indian advertisement, you might have seen a lot of Symphony air cooler, purchase Symphony air cooler, install in your home, enjoy your life. Correct. This one, it is evaporative cooling only. Evaporative cooling. How the system is working? This one is having a basin. Correct. Within the basin, we are having water. At the same time, we are having a small pump as well. Left side, right side, back side, everywhere we are having cooling fills. Cooling fills. In engine, we used to call that as fins. Make sure your mic has muted. Please. Okay, this is called fills. Why we are using this one? Fills we are using in the side wall of desert coolers to increase the surface area of contact between air and water. Okay, this one. So when the system is working, when the fan is rotating, it will be taking atmospheric air through this way. And at the same time, the pump that we are having in the basin will be taking the water, and the water will be eventually dripping down. So air will be carrying this water. Little amount of water will evaporate. Means when it is spraying the water, the little amount of water will be evaporating. By that process, we will be getting some cooling effect. Using that cooling effect, we can cool the space. Correct. But the problem, there is a term called RH. RH is called relative humidity. Relative humidity. For example, okay, if you are going to gymnasium, okay, you started lifting weight. Maximum 20 kilogram of weight you can lift. Correct. That is your maximum weight carrying capacity. Atmospheric air is also having that limitation. 1 kilogram of air, it is not possible to carry 1 kilogram of water. Grams of water only it can carry. But that is totally depending upon the atmospheric temperature and pressure. Let's say in a particular atmosphere, let's say like 35 degrees Celsius of temperature, at 1 bar pressure, each kilogram of air can carry maximum 8 grams of water. That is the maximum weight carrying capacity. So whenever at this state, each kilogram of air is having 8 grams of water, you can say the air is saturated. Air is saturated. But it doesn't mean that always the air is saturated. Sometimes each kilogram of air might be having 6 grams of water. Sometimes each kilogram of air might be having 2 grams of water. Sometimes each kilogram of air might be having 4 grams of water. For example, your maximum weight carrying capacity at the gymnasium is 20 kilogram. Whenever you are playing with the 20 kilogram, you can say you are saturated. But it doesn't mean that you are always playing with the 20 kilogram. Sometimes you might be playing with the 10 kilogram. Sometimes you might be playing with the 5 kilogram. This condition, the relation between the present condition, the relation between the saturation condition, that condition is called relative condition. For example, in terms of humidity, each kilogram of air can carry 8 grams of water. But when I am measuring at present, each kilogram of air will be having just 4 grams only. So 4 divided by 8, you will be getting a value 0.5, or that is called 50%. So 50% relative humidity means atmosphere is already having 50% of water vapor in it. Still it can carry 50% more. 75% relative humidity means atmosphere is already having 75% of water vapor in it. Only 25% of space is remaining. 100% relative humidity means atmosphere is saturated. It is already having 100% of water molecule in it. It can't hold any more water. This term is very important. Understood the concept of relative humidity? Relative humidity is the ratio between the present humidity and the maximum carrying capacity. Correct. This term is important. Why it is important? For example, you can imagine desert cooler will be producing the cooling effect by air evaporation only. Air evaporation, the water temperature also matters. For example, initially when you are placing this desert cooler within a space, the water temperature might be like 25 degrees Celsius. Your room temperature might be 35 degrees Celsius. But after some time, the water temperature and the room temperature may constant. Means equilibrium may happen, but depends. That is another story that we can study. And also, the majority of heat or the cooling effect that we are getting within the space is by evaporation only. Because the water will be trying to evaporate. When it is evaporating, the water will be absorbing latent heat from the surrounded water molecules. That's why we will be getting a cooling effect. The room cools for a certain extent. But the problem, when this desert cooler is simply spraying the water within the spaces, the relative humidity within the space will increase to nearly 100%. So once the room relative humidity has reached 100%, the evaporation process will not happen. Because the water molecules will try to evaporate, but atmospheric air will say, dear water, I am already having 100% of water molecules with me. Please don't come, don't evaporate. That's why at 100% relative humidity, the evaporation will not happen. As long as if the water is not evaporating, you are not going to get any cooling effect there. Understood the concept? Because whenever the water is evaporating, it will produce a cooling effect because the water will absorb heat from the surroundings. That's why we are getting the cooling effect. So in desert cooler also, initially you will get the cooling effect because the water will evaporate. But when the water is evaporating, all this water will be coming as a moisture to the space only. So the room or the space relative humidity will increase from the starting. Initially, it might be 60%. Okay. Later, the room relative humidity will become 100%. Once the room relative humidity is 100%, the atmosphere will say, or the room air will say, I am already having 100% water molecules with me. There is no space remaining. So if the relative humidity is 100%, water will not evaporate. If the water is not evaporating, you are not going to get any cooling effect there. So that is waste of energy. It is waste of energy. So once the relative humidity within the space becomes 100%, the next process that is going to happen is it will be simply spraying the water somewhere near, and also it will be wasting some electricity. Correct. So it is not an effective cooling technology. Rather, it may create some discomfort for the people because once the relative humidity is very high, if the relative humidity within the space is very high, it may create some sinusitis issues. And also, if you are having like a lot of cotton cloth, linen, whatever the material it may, the water molecules humidity will be accumulated there. Eventually, that may enhance the fungal infection, algae growth, everything. Correct. So that's why desert cooling or evaporative cooling technology is not good for human health, and it is not an effective cooling technology. Starting 5 or 10 minutes, that is fine. Otherwise, you can do one thing, keep your window open. Keep your window open, then atmospheric air will be entering inside. So we will be having air circulation. Up to a certain extent, we can maintain the relative humidity within the space less than 100%. The water will evaporate. But if the atmospheric air is entering inside, it will not create the comfort, right? So that's why it is not an effective cooling technology. So in case of air cooling, ceiling fan has failed, desert cooler has failed. Not only that, see, we are having a term called, if you are using your desert cooler, you will not create comfort, because the comfort the system will make worse. We are having a term called feels like temperature. Feels like temperature. Okay. Let me select it. For example, at present, I'm staying in Trivandrum. Okay. Trivandrum weather now. It is like 27 degrees Celsius and it is having 85% humidity. But what exactly I feels like temperature, 27 degrees Celsius air temperature and 85% humidity, I might be feeling nearly 30 degrees Celsius, because that is due to the moisture that is present in the atmosphere. But in the same room, if I am trying to use a desert cooler, air temperature, atmospheric temperature is 27 only, but the relative humidity might be increasing to 100%. On that time, instead of 27, I might be feeling 33 there. Correct. Sometimes, see, in summertime, let's say the atmospheric temperature might be 33 degrees Celsius, relative humidity might be, let's say, 60%, say example. So I might be feeling 40 degrees Celsius then. Atmospheric temperature is 33, relative humidity is 60. Since the relative humidity is high, so we might be feeling 40 degrees Celsius there. But in that time, instead of purchasing an air conditioning machine, I might be thinking that I can purchase an air cooler, desert cooler, evaporative cooler, then I can use inside. But when I am using inside, eventually for starting 5 minutes or 10 minutes, I will be getting the cooling comfort. But once the relative humidity within the room is nearly 99%, I might be feeling 59 degrees Celsius instead of 48. Then whether to use it or not? Why we are wasting your money? We are simply wasting your money, because air cooler is not a perfect cooling technology. So don't waste your money. But still people are using it. We can't say anything yet. Okay, so that is not a good technology. Any other cooler? Yes, Peltier cooler, Seebeck effect. Peltier cooler systems we are having. Normally this one is a very minimum cooling technology. So you can see ice is accumulating there. As much as minus 18 degrees Celsius also possible with this. But this one we are using for cooler masters and all. Cooler masters, DB, distribution board cooler, computer, no, workstation computer, to cool the processors and all, we are using this one, because it is not having that much efficiency. The efficiency is like less than 70%, 60% only. But the concept is like a Peltier effect or Seebeck effect only. You can purchase this from eBay, Amazon with very correct 235 Indian rupees and like $3-4 it will come. The advantage is, one side when you are providing the electricity, DC current, other side in this sink you will be getting the cooling effect. That cooling effect you can use to cool the substances, whether water or air. But very large point, like 1 ton of refrigeration, 2 tons of refrigeration, that much amount of heat, it is not practically possible. Correct. Yes, this is also a cooling technology only, but it is not that much efficient. Very high capacity cooling is not practically possible since it is not efficient. Peltier cooler is a cooling technology. Any other thing? Vortex chiller is there. Vortex chiller. Vortex chiller is a compression technology or air expansion. Vortex chiller, normally we are using in distribution board cooling, DB, no, mini electronics component, server area, server rooms and all, computer server rooms, we will be having small distribution boards. Always the temperature within the distribution board has to be maintained perfectly. Correct. DB, this is a DB board. Here you can see this one. How the system is working? Nothing. Because you need an air compressor. Air compressor. Through the air compressor, the high pressure air will come. And through this vortex tube, the air will expand. So when the air is expanding, the pressure will decrease. The pressure is decreasing, the temperature will also decrease. That's why if the cooling effect is producing by the help of air expansion, that tube is called vortex tube. The disadvantage is if you need to produce a compressed air, you need an air compressor. So comparing to the vapor compression system, we can study those systems in the upcoming classes. This is not efficient. Nowadays, we are using for, not in India and GCC, some European countries, we are using this one for DB, distribution board cooling. Okay, vortex chiller. So it is not an efficient technology since it is inefficient. Any other technology we are having? Yes, geotechnique or geothermal energy. Geothermal cooling system we can have. How the system will work. For example, if you're having a home, okay, bedroom, I'm having a cooling coil there and a blower fan. Okay. By the help of a pump, I'll be taking this cooling coil downwards to the earth. This is soil only. 5 meter, 10 meter below, I have connected a cooling coil. Then the same cooling coil will be coming back to the pump. It's a pump bolt. And this is my cooling coil. See, from the earth's surface, if the depth is increasing, the atmosphere, the temperature of soil will increase. For example, it might be like a 10 degree, 14 degree, on that range only it will come, or 15 degree, 16 degree. It is less only. That one we can utilize. How? Inside this coil, it's a closed loop only. It's a closed loop. We will be filling water. Okay. Now this pump will be taking this water through this way. Let's say, since the water is coming through this cooling coil, that water temperature that is circulating will be like, let's say, like a 20 degrees Celsius, example. So this 20 degrees Celsius of water will be going through the cooling coil. At that time, what this fan will do, let's say the room temperature might be 35 degrees Celsius. So this 35 degrees Celsius of air, the fan will be circulated through the cooling coil. So the air temperature will decrease, right? Since the water temperature is 20, air temperature we can achieve like 24 degrees Celsius because now cooling is having 100% efficiency. Approximately can become 24. Yes. So by absorbing this 35 degrees Celsius of heat, the water temperature will increase. From 20, it might become like, let's say 30 or 33. So this 33 degrees Celsius of air will be coming back to the soil. Since it is circulating through the soil will be absorbing this heat. Again, the water temperature will decrease. We can achieve this cooling. Not only this, if you are having any river, any water flowing structures you are having near to your home, like a stream or a river or a pond, you can dip this in that water. Accordingly, also you can create it. But you might be thinking that you are having a bore well or a tube well in your home. Yes, that water also you can use to cool your spaces. Practically possible, but geothermal energy or cooling system, we should not enhance that one, or we should not motivate this, because if the soil temperature, we have already taken most of the land. We have almost taken the ocean now. Now we are exploring towards the space. Leave some substances we are having in soil, beneath the soil. So if the soil temperature is increasing, definitely that will affect the organisms that we are having in the earth. So that's why yes, it's a source with a very minimum electrical consumption. You can use this. Okay. See, whether it is a ceiling fan, direct cooling, or if it is a desert cooler, evaporative cooling, or if it is an air expansion cooling like a vortex chiller, or if it is a Seebeck effect like a Peltier cooler, or if it is like a geothermal technology, all these technologies are not effectively removing the humidity level within the space. If you want to create comfort for the people, not only the temperature we have to maintain, along with the temperature, the relative humidity is also important. I told before, why? Because whenever a person is doing a heavy activity, their body temperature will start increase, correct? Normally, the human body temperature is 37 degrees Celsius only. Whenever our body temperature is start increasing from 37 degrees Celsius, our body itself, our brain itself will start taking the measurement to decrease it. How? Brain will give the signal to the nerves. From the blood itself, the water molecules will be coming on the skin surface. Correct. That is called sweat. Through the sweat holes, the water molecules will be coming on the skin surface. Now, this sweat or the water molecules has to evaporate. So if the sweat water molecules has to be evaporated, it needs latent heat of evaporation. So that latent heat of evaporation, the water molecules will be absorbing from the body. So the body will be losing the heat, the body temperature will decrease, body cools. That's why our body is effectively using the latent heat of evaporation to remove the body temperature or to decrease the body temperature, correct? But you can see, if the atmosphere is already having 100% of relative humidity, what will happen? Especially when you are working in the summertime, people will be saying that I am sweating more, I am sweating more. You are not sweating more. Because comparing to they might be comparing with the winter to summer. Winter time we will not be sweating. Summertime we are sweating more. The process of sweating, whether it is in summertime or if it is in winter time, or you are in India, or you are in GCC, or you are in space. Whenever you are doing a heavy activity, with respect to the metabolism rate, your body temperature will increase. But especially in summertime, in some countries, especially if you are having a marine exposure and all, the relative humidity is very high. So you are doing some running or you're jumping, whatever it may, you will sweat. But when the sweat is trying to evaporate from your body, atmosphere will say, dear sweat, I am already having 99% of water molecules with me. Just 1% of space is remaining. So what will happen? Your sweat will not evaporate. So since the relative humidity in the atmosphere is very high, the sweat will not evaporate. If the sweat is not evaporating, the sweat will not remove the latent heat of evaporation from your body. So your body temperature, it is not possible to decrease. You will not feel the comfort. What will happen? If the sweat is not evaporating, the sweat will be slowly flowing from your body surface. So since the sweat is flowing down, you might be feeling that you are sweating more. Actually, you are not sweating more. Rather, your sweat is not evaporating. That is the reason behind it. So in that scenario, your body is not the reason. Atmosphere is the reason. At the same time, in winter time, you might be running like anything, 3 km per hour or 20 km per hour or 40 km per hour. You might be running like anything, or you might be feeling that you are not sweating. The real reason is sometime in the winter time, the relative humidity, let's say that is 30%. If the relative humidity is 30%, atmosphere will say, dear body, dear sweat, 70% of my space is remaining, come fast. So in that scenario, your sweat will come. In atmosphere, we are having lot of spaces. So what will happen? Your sweat will be suddenly evaporating to the atmosphere. That's why the rate of evaporation of water molecules, whether that is pure water or if it is sweat, rate of removal of latent heat from the body or the latent heat of evaporation will totally depends upon the atmospheric relative humidity. Correct. The relative humidity in the atmosphere is very high. The evaporation of sweat from the body will be very less. So people will be getting, you can imagine when we are designing a gymnasium, people will be doing very heavy activity within the gymnasium. So in that scenario, if the surrounded temperature within the gymnasium is very high, the people will not feel comfort there. That's why along with the temperature, for example, if you are having like a 20 degrees Celsius within your space, it doesn't mean that you are feeling comfort. 20 degrees Celsius at 100% relative humidity, what you feels? 20 degrees Celsius temperature with the 100% relative humidity, you will feel nearly 21 degrees Celsius. Okay, somewhat that is fine. But if it is 25 degrees Celsius, that might be 20. That is good. No, 25 only you will feel. Okay, fine. That is also good. If it is 30 degrees Celsius with the 100% relative humidity, you might be feeling 44. So that's why the relative humidity in the atmosphere also matters to create comfort for the people. So all the equipments that we have discussed before is not having any control over the humidity. It is having control over just the temperature precisely. So we are not simply dealing with the air cooling. We are dealing with the air conditioning only. Okay. Air cooling and air conditioning is different. Air conditioning means a lot of parameters. For example, temperature has to be adjusted. Humidity has to be adjusted. Then the velocity of air that we are means delivering through the space has to be in minimum, because when the air velocity is very high, it may create some draft effect and all. We can study all the sound it may create. And we have to maintain the sound in the minimum cases. And also odor. Odor, no, smell. Smell has to be a problem. See, all these things has to be maintained. Okay. Indoor air quality maintained perfectly. Fresh air, no? Yeah, fresh air. That is called IAQ. Fresh air has to be introduced inside. So all these parameters has to be maintained. Okay, ventilation. Correct. So what all things that we can do to provide all these things, that everything we will be dealing with the AC, air condition. Understood? Okay. Now we can move to standards. What's the importance of a standard? What is standards? Standards are not for by-hearting. Rather, when you are proceeding your work or your job, we can take the data from standards, then we can proceed our job. Okay, for every batch I used to, for example, you can take like a concrete slab as a reference. Concrete. Okay, normally the conventional concrete slab is M20 slab only, M20. M20 means concrete grade only. M10 grade, M20 grade, M15 grade, M30 grade. M20 is like, I guess 1:2 is 1:2 is to 3. It's a mixing ratio. M20 grade concrete, the ratio will be 1:1.5:3, not 2, 1:1.5:3. That is M20 grade concrete. Means 1 part cement. For example, if you are taking a measuring bowl, in that measuring bowl, 1 part cement, 1.5 part sand, 3 part aggregate. Then we can mix. That's why. So if the grade of the concrete is varying, the mixing ratio will also vary. Normally, all the conventional slab that we are using in the building is M20 grade only. M30 grade is also there. The mixing ratio is slightly, concentration is more. Cement concentration is more there. M30 grade concrete we are using for water retaining structures like hydroelectric dam construction, water retaining structures only. So this 20 is representing the compression strength of the concrete. 20 kilonewton per meter square. That is nearly 20,000 kilogram. It is compressive strength only. Concrete is having very high compressive strength because it is very difficult to fail the concrete by compressing it, because it is having very high compression strength or compressive strength, but it is having very less tensile strength. By twisting it or by bending it, you can easily fail the concrete. That's why to increase the tensile strength of concrete, we are introducing steel inside. That is called reinforcement. So when we are introducing the metal steel bars inside, steel is having high tensile strength. So that's why, since we are introducing steel inside, the tensile strength of concrete we can increase, right? There are also horizontally, vertically, transverse and lateral linear direction we will be introducing it. What should be the diameter of this one? Anyhow, if you want to find the diameter, you can take a small section. How much load it is going to apply there? Okay. Let's say this is a meter square. Each meter square, like 5 kilonewton of heat or load we have to apply. That we have to calculate with respect to the type of building. 5 kilo means, or another way, each metal bar has to withstand nearly 1 kilonewton of heat. Okay. Example. And after that, we will be taking different diameter metal rod by the help of universal testing machine, UTM machine. Using hydraulic force, we will be loading UTM this. For example, each metal bar has to withstand 1 kilonewton of load. So I have taken 6 mm. Then I have taken 8 mm diameter. 8 mm is the diameter of bar only. Diameter. Okay. 8 mm, 10 mm, 12 mm. So I have loaded 6 mm, then I applied load. It failed. I have loaded 8 mm, I applied load, it failed. I have loaded 10 mm, it passed. Then I can use, because when you are loading it, when you are applying this load, that metal bar may fail. Engineers might have studied this in the strength of materials laboratory. Correct. Might be. In my syllabus, it was there. I guess in most of the mechanical engineers are studying it. I guess electrical engineers, it is nil. Civil engineers are also studying. Anyhow, it is not the part of, but mechanical engineers has to study the strength of materials. That's why we are studying it. Okay. But you can imagine, so each and every bar, we are going to test it like this, how much time it will take. Because the load that we are going to apply in every slab is not uniform. It may vary, right, with respect to the furniture load, number of people. That's why we are having standards. With respect to the load ranges, you can go to the standards. From the standards, we can take data, whether that is Indian standard or if it is like a EN standard, British EN standard, international standard. We have, with respect to the load ranges, we can take the data and that diameter we can use to proceed for our job. Correct. Means lot of unnecessary calculation and testing procedures we can avoid. Rather, simply we can take data from the standard. Accordingly, we can proceed our job. Correct. So standards will make our work easy. Fine. So what all major standards that we are using in HVAC? Very important standard is ASHRAE, American Society for Heating, Refrigeration and Air Conditioning Engineers. It is a USA standard only. They have implemented this standard in 1880s. That is 1.4 century back. Okay, that's a very important standard. American standard. Then we are having ISHRAE, Indian Society for Heating Refrigeration, because India, each and every countries might not be having their own standard. We will be studying ASHRAE only because we will be studying as per India also. Most of the consultancies are using ASHRAE only. But India, we are having our own standard. Every countries are not having it because in India, like Kashmir to Kanyakumari or like Arunachal Pradesh to Gujarat, we are facing very, very versatile climate. Kashmir, we are having very hectic winter time. Okay, middle side, Rajasthan, it is very near to the equator. So we are facing very hectic summer time. And in Arunachal Pradesh, like 7 sisters that we are having, Nagaland, everywhere, we are having like a monsoon, correct? Himalayan presence also there. And like Gujarat, Kerala, like we are having sea exposure there. So monsoon we are facing in Kerala or like in eastern side. Sorry. This one here, southern side. And this Gujarat side and all, we are having sea exposure. So very humid condition we will be facing there. So that's why we need our own standard for our purpose. So India is having our own standard. It has implemented in 1980s. That is called Indian Society for Heating, Refrigeration and Air Conditioning Engineers. Okay. So when we are designing almost all the HVAC design, we have to take data from ASHRAE. And if you are doing Indian project, ISHRAE also. But ISHRAE, even though 99% of consultancies that we are having in India are following ASHRAE, government projects, they might be following some ISHRAE data. Okay. Fine. So that one, heating and cooling load calculation, duct sizing, air terminal selection, ESP calculation, pump selections, whatever it may, acoustics, whatever it may, we are taking data from ASHRAE only. Okay. The next one, DW144 and SMACNA. These are duct construction standards only. Experienced professional might be familiar with this one, but freshers might not. You know HVAC duct, you might have witnessed to this before. This AC duct. To transfer water, we are using pipe only. To transfer air, we are using duct, supply air duct, return air duct, exhaust air, fresh air, car park exhaust, means stairwell pressurization, lobby pressurization, smoke exhaust, a lot of duct systems we are having. And also different duct material as well. GI, galvanized iron, that is also hot dipping, electroplated. With respect to the gauges we have to select, on what distance we have to provide the supports. Different material like a pre-insulated, PI, polyurethane foam we might be having. Or stainless steel is there. SS, MS, FRP, GRP, PVC, concrete. Lot of duct material we are having in the industry, aluminum, copper. Okay. So when we are doing the duct construction, every duct we will be sizing with respect to the flow rate, sound criteria, NC level, maximum permissible delivery velocity, 2-3 parameters we have to consider. Based on that only the dimension of duct we will be calculating. Correct. For example, when you are working in building information modeling, when you are selecting a duct system, here you can see we are having an option called duct sizing. The option is there, but you should know what method you have to size it. Whether it is equal friction method or velocity reduction method or equal friction, only equal friction, or only static regain, or along with the friction, velocity also has to be considered. You should know this data, then only you can do that, right? And also, Revit is not a modeling, it is not a design tool, it is just a modeling tool only. Design, we have to use another softwares. Okay. That's why when we are doing the duct construction, if the airflow rate is increasing, means the quantity of air that we are distributing through the duct, accordingly, the dimension of the duct will vary. If more airflow, bigger duct, less airflow, smaller duct. Every dimensions, we can't use the same thickness. So with respect to the dimension of duct, what thickness has to be selected? What gauge has to be selected? On what distance we have to provide the support? Distance between the support. What should be the diameter of the rod that we are using to provide the support? What type of support we have to use there? Whether that is a stirrup, or if it is a bar, or if it is an angle, all these construction data we are taking from these two standards only. DW is a BS standard. SMACNA is a USA standard. Duct Work 144, it's a British standard. SMACNA, sheet metal, air conditioning, contractors, national association, it's a USA standard only. But in abroad, mixed, some consultancies might be following BS standard. Some consultancies might be following SMACNA standard. Okay. Anyhow, this data we are taking from the SMACNA only. Fine. The next one, ASHRAE 62.1. We have discussed the importance of ventilation, indoor air quality. For example, when you are designing a particular space, as I told, to maintain the indoor air quality, we have to introduce oxygen-rich air to the spaces. How much it is? Matters, right? That's why with respect to the space that we are designing, each person, how much amount of air has to be provided? Each meter square of land floor area, how much air has to be provided? We have to add together. Accordingly, only we are calculating it. Okay, that's why ASHRAE 62.1 is a ventilation standard. Once in every 3 years, they will be updating it. Whatever it may, the base value, it is not going to change. Okay, so when we are designing our ventilation systems, we will be taking data from ASHRAE 62.1 only. Clear. Now, ASHRAE 154.